everyone, and with version 16, Houdini changed quite a few things. Some of them are like the big ones, like you have the hair and fur and stuff like that. But some of them are fairly small, but really fundamental to like the day-to-day working. And one of those is the group node. So this video, I primarily want to cover the group node and the changes that have been made to it. This is also applicable to anyone who has any of my trainings, the commercial ones, because you use groups a fair bit. So this will sort of help you get or help you adapt those older trainings to the new ones, especially in the places where you get stuck using the group functionality. So let's get started. I'll just create a grid and we'll basically just work on that. Okay, so I'll give it a few segments. So let's say about 30 by 30. All right, so what was earlier a single node has now been broken up into multiple nodes. Okay, so what you get is you get the basic group node, which has something called as base group, and then you have which is essentially like selecting by pattern. And then you have the other things like you have bounding box over here, you have normals and edges. Edges is useful when you want to do bevels on edges after a poly extrude, so that's where this little thing comes in. The other stuff, like you have group by range, so that is now a separate node. You have group by expression, which is also a separate node. The group by expression node is actually just a modified attribute warp. Like if you double click on this, you can jump in and you'll see like it's basically an attribute warp. And then the few other things, like if you want to combine groups, that is separate as well. So you get a group combine, which is separate. And lastly, if you want to convert groups, like if you want to convert a point group to a primitive group, that is now called a group promote. Okay, so that comes in here. So what was earlier one node is now 5. So in this video, I'm going to try and cover all of these. So you get a good enough idea of what you can or can't do. So let me get rid of these. We'll start off with the basic group node. Alright, so what you get on top, as I said, like this is basically pattern selection. So if I do something like, if I specify a pattern, let's say 0 to 100, so you can specify a pattern. You can also do a little bit of like a range type selection here. So let's say if I do 0 to 500, but I want to select one of every two. Okay, so I can do a colon and type 2. So that will give you this. Okay, so you can do like 0 to 500. You can't do something like an n, like 0 to, and you also can't do something like endpoints. So expressions don't work here, so you can't do any of those complicated things. So you can't do like random selections and stuff like that. But you can do some basic stuff. Like if you want to do 0 to n, just type in a fairly big number. That will give you like a 0 to n. Okay, you can also do a few other interesting things, like if you take this function, okay, I don't know what it's called, but that one. And then if I specify another range, then that will get omitted. So if I say 60 to 200, okay, see, so it's selecting this much and then it's omitting 60 to 200 and then selecting further on. Or if you want to select everything except a certain range, then you can do an exclamation mark. So you do exclamation mark and then you say 50 to 250 and enter and see. So now you're not selecting that much. You can also do a little bit of expression work. Okay, so let's say, let's do one thing. Let's call this T and we will use a color node just to see or just to sort of visualize it. And I'll take T and just color it blue. Okay, so that. And let's change this to primitive. The nice thing about the color node is it does like an auto conversion. So even though my selection is points, even though my selection was primitives, it can assign the same thing to points. So it converts that thing internally, automatically. You don't have to worry about that. Unlike, let's say, like a poly extrude. Like a poly extrude looks for a primitive group. If you feed a point group into it, it can't recognize it. Okay, but the color node can do like an auto convert. Okay, so if I do something like I want to select everything, say positive of z axis. Okay, so I can do something like at p dot z is greater than 0. So it doesn't select anything. Okay, now the problem is for expressions, it only works with points. So if I change this to points, still nothing happens. That is because you can't keep any spacing here. Okay, like when you type in the wrangle SOP, you can keep spacing. Okay, but here you can't. So you have to have no spacing, and see, now it works. So this is technically a point group, but as I said, like the group SOP is converting it to, sorry, the color SOP is converting it automatically to primitives because I've kept the color assignment to primitives. So you can do stuff like this. But let's say I want to extrude this. Okay, so I want to convert it to a primitive group. Okay, so like if I take a poly extrude and if I try to extrude this, like you can't find the group because it's a point group. Poly extrude won't understand it. Okay, so what you do instead is you take a group promote, and here you can convert like a point group to a primitive group. So we'll say convert from points to primitives, and the group name is T. Okay, and if I don't give it a new name, it will keep the name T. Okay, so if I come in here and then I can select T and I can extrude it, and there you go. Okay, so let's say if I make it say individual elements and give it a little bit of inset, and then I can just take a transform here just to show you that it's working, and then we can just move it. See. So whatever, like if I take a sphere, see, so you can do, basic stuff like that. So I don't fully understand why it's been broken up. Maybe it gives you a little more, procedural approach to the whole thing rather than everything being in a single node. And maybe it uses lesser memory. I'm very sure of that. Okay, like maybe the calculation time is faster because each node separately takes up lesser memory. I'm assuming that's the thing. Okay, but yeah, so that's your group node and that's the group promote. You can also do basic color based selection. So let me just come in here and let's try to do something else. Okay, so what I'll do is let's come to the group. Let's stick to color, and let's say I want to give it like a little bit of noise based color. Okay, so let's take a wrangle. So I can take an attribute wrangle, and we'll do something like @cd is equal to, you can do a noise function. So just type in noise, and we want the position to be fed into it. So just do like @p, okay, and semicolon and control enter. So that will give you, sorry, keep it on that. There you go. So you'll get some noise. Now I would like to select this. So if I come into the group node, and now we have that, but we want to select the color. So I can do @cd.r is let's try less than 0.5, and that doesn't work. Okay, so it can't read cd.r. Okay, you have to type in cd.x. So it reads cd.x, y and z, but it can't read RGB. Okay, so which is a very odd thing. So yeah, so when you want to get to the elements, either you have to do like a cd and square brackets 1 2 3, or sorry 0 1 2, or you do cd.x, cd.y, cd.z. So just remember that, like typing the R doesn't work. So there you go. If you do cd.x, so x is red and y is green and z is blue. Okay, so we get this. And then if we come to color, you can just say delete existing attribute. See, so we'll get that. So if I increase the grid functionality here, we'll get something a little nice. And I can do, yeah, let's come to group. We'll say less than 0.6, no, 0.3. Wow, too less. 0.4, yeah, okay. So yeah, see, so you can do cd.x, cd.y and cd.z. So you can do any of them. And we can, let's keep it to x. Let's try 0.45. And then let's say if I come in here and do a poly extrude, so you will get this. So you can do some basic stuff. Plus if I come to, let's say if we come to wrangle, and I'll do a plus at time, so which will allow us to animate it. So if I press play, like I'll switch on the real time and press play, see, you'll get an animated noise. So you can do, stuff like that. Okay, along with this, you can also sort of mix it with your bounding box or normals or stuff like that. So if I come to enable bounding box, See, so I can specify like an area for it. So I can do bounding box, I can do bounding sphere, any of those things. So now your animation is just within that. Alright, so this is the basic group node and the group promote. Okay, now again, like if you want to invert this, so I can take a group combine. Let me plug that in there. Okay, let's say I want to invert this. So I will say group S is not equal to T. And let's come in here and I will take the group S. And here I'll take S. See, so now you're getting like the opposite of that. So yeah, so that's how you do your combines and stuff like that. Okay, so let's keep this to T and let's go back to T. Okay, then you get the range. Okay, so if I take a group range, so this is fairly simple. I haven't explored it fully because it has quite a few options in here. Relative start and end is what you generally want to keep to. Like earlier what was 0 to n is now like 0 to 0, which is it starts at 0, goes all the way around and comes back to 0. Okay, so you don't need to have like a $n anymore. And then you can just specify. So if I say 1 of every 5, see, so you're getting 1 of every 5. Okay, and let's just try to put like a color in there. Let's call this T as well. And let's try to put color. See, so there you go. And you can also offset it. And the interesting thing is that you can have multiple of these. So if I click plus and then I can say like this is T and then let's say this is S and this is 1 of every 2 or let's try 1 of every 8. So we can't visualize both of them, but I think if I take a color, okay, so let's take another color and let's say this is S and primitive and let's try green. So we are selecting 2 of them. So you can actually have like multiple groups overlapping. And you can also do like an offset, so which animates everything. So which is kind of interesting. Okay, so you can do stuff like that. Now here you end up with one of the more specific things which I have used in quite a few of my trainings, which is how to select the first point and the last point. So let's say if I take a line, like earlier it used to be you do $n minus 1. Now that is not available anymore, or at least I haven't found if it's there. So what you do instead is, let's say if I have like 20 points and I'll take a group range. Okay, and we will keep this to points. And the only way to do it is to use like an endpoints function. Okay, so what you do is you take endpoints, which allows you to calculate the total number of points of any node. So we will point it to line 1. So it's endpoints and then you do your inverted commas and / line 1 and close it and you do a minus 1. So whatever is the total number of points, 1 less than that. And if you press enter, sorry, it's endpoints, P-O-I-N-T-S, not endpoint. That's why the problem is. And see, there you go. Okay, so now if I come into the group and I press I, and you will have group 1 has 2 points. Okay, if I try to do a copy, you'll be able to see it. So if I take a box and I do a copy, now even the copy has changed, but not in a big way. So you have 3 versions of them. Like copy stamp is the old one that we had. Copy to points is only, like points. You don't have any of the other stuff. This is, as I said, this is not very complicated. Okay, so you just connect the points in here and then you pick the group. So we have group 1 and there you go. Okay, so if I make this small enough and then no matter the number of points in here, okay, if I increase it or decrease it, see, so we're selecting the start and the end. So this is what you need to do. You take an endpoints minus 1 and that will allow you to select the first and the last. Okay, so this is group range. And then the last one we have is basically the group expression. Now, the group expression is, I am not entirely sure if we need it anymore. Okay, because and this I sort of learned from the Entagma videos, is that you can actually make groups within the Wrangle SOP. Okay, so Either you just type it slightly longer in the wrangle SOP, or you use the group expressions. They both do the same thing. Okay, so it's kind of, I'm sort of wondering, like, do we really need it anymore? Okay, but yeah, we'll just sort of look at the group by expression, because the group expression then allows you to do a fair few things, right? So if I take a group expression, again, this also has options to make multiple groups. Okay, so you can keep, specifying. So let's do one thing. Let's put in the wrangle SOP here, like the noise that we had used. So we have like a little more, we have something to play with. And I can give it a group name. So let's say T. And then you do the same thing. So let's say if I want to select random polygons. Okay, so I can do random, let's keep it to points. So you can do random at pt num less than 0.5. And here you can keep spacing. So there you couldn't, but here you can. Yeah, and you can have it at, points or primitives. It's pretty much the same thing. So if I come in here and this is T, so if I do group promote at T, and then, there you go. Okay. And then again, if we come in here and if I do something like a plus at time and enter, and then you'll get, this happening. So you can do all of that stuff here within the group expression. But as I said, you can also do it at wrangle level, right? So if you know the syntax of it, you can very easily write groups in the wrangle SOP. The only thing you can't do is it doesn't visualize it. Like here, when it selects it, you get a visualization, right? So like you know what is being selected. The only thing that happens there is you can't visualize it. But you can always add like a color node at the end of it and see what's happening. So yeah, so just to show you how you can do this stuff within the wrangle SOP. Okay, so if I come in here, which is my wrangle. Okay, so let's say if let's take a brand new wrangle. Okay, so we'll do an attribute wrangle here separately. So the functionality is fairly simple. Let's say if I want to do a selection like before. So we want to do everything positive of Z axis. So to declare a group, it's a float value. So you do F, okay, like small f at group, and then underscore and whatever should be the group name. So we do T. And if I just do equal to 1, that means it will select everything. Okay, so if I just come in here and I click on I, see you have 2352 points, and this is 2352 points. So it selected everything. So if I do something like at p dot x is less than 0, and if we take a color and we keep this to T and we give it a color, see, there you go. So if I do p dot y won't work, it's flat. So p dot z. And if I want to do other things, like if I want to do random at pt num, okay, less than 0.5, and remember to put a semicolon at the end of it. Okay, so there you go. Okay, and then if I change this to primitives, so you get that. Let's go lower, 0.3 or 0.2, and you can also turn this into a primitive selection. So if I change this to primitives, see, now you're selecting primitives. So you can do, like, the point I'm trying to make is, like, the group expression node is not really needed anymore. You can pretty much do it in the wrangle SOP. So you don't really need to do it there. And you can have multiple groups. So if I select this, let's do Control C, and then we'll come here and do Control V, and let's say this will be S, and we'll do random $pt plus 7 less than 0.3. And if I come in here and I change this to S, see, so you get a different selection. So if I do a poly extrude, that should be interesting. Let's see if we can do 2 poly extrudes with these groups. So let's take S and we'll do an extrude, and then we'll do another poly extrude. And okay, so that's using T. Let's do S. See, so you have like one extrude and another extrude. Okay, and then if we come into the wrangle and if I make changes here, let's say this is 6. See, so you change your selection. So yeah, the point being, whatever you were doing with the expression SOP or whatever you're doing with group expression, you can do it in the wrangle SOP. And the nice thing about the wrangle SOP is you can do multiple things within it. So let's say if I want to give it like a gradient, okay, going from like a bounding box gradient. So within this itself, let's say if I type in at CD is equal to, if I just give it a bounding box, it will take up everything. So the red color will come automatically. So if I just do relative B box, the way it works is it needs to know which of the inputs it's supposed to use. So we have only one input right now, so that's 0. And then the bounding box of what? So that is the position. So at P, and then again like the semicolon at the end, and there you go. If I want it only for one color, okay, so what I can do is I have to do like a set, and this is X, and let's see if this works. So comma 0, comma 0, and semicolon and enter, and there you go. So now what you're doing is you are specifying X, Y, Z. So this is only for X, and this is Y, and that is Z. And then let's say if I want to set another group, so let me just pick this up. Let me do Control C, Control V, and let's say F at C, and we'll do at CD. Let's try greater than 0.7. Okay, let's do one thing. Let's change this to points for now. Okay, yeah, it wasn't selecting it at. So let's do one thing. We can promote it. Okay. So I think if I come to color, and if I set this to C, and if I delete it, and we say delete existing C, so that's what it is doing. So yeah, so this doesn't work at primitive level. I think it was causing problems with primitives. Well, not anymore. Okay, that's kind of strange. Let's see if it extrudes it. We'll know right away. So if I take a poly extrude again, and let's pick up C and extrude it. There you go. Okay, I don't know why it was giving an error. It was giving an error. So you can do stuff like that, and then you can also do, since we are doing this much as a final thing, let's say if you want to do something like you wanted to scale down based on the red color values. Okay, so let's pick up a little more. So 0.5. Yeah. So what you can do is you can declare an attribute called Z scale. Like if you come to local control and you have something called as Z scale, okay, which calculates based on whatever attribute you have. So what you do is you come into, again, the wrangle SOP, and then we can just do F at Z scale is equal to at CD dot R, because it's the red color. And sorry, I keep typing capital F. There you go. See, so now we have, yeah, you're supposed to control enter. I accidentally pressed enter, but there you go. See, so now you have this. So yeah, the point being, everything else is fine. You know, you have the normal group, and then you have the group range, and the the promote and the combine. But the group expression is the only one which is kind of tricky, because of course it gives you options like you can replace and union with existing and stuff like that, which is useful. But generally when you are doing groups based on expressions, you can always do it through the wrangle anyways, because as it is you're typing expressions. Okay, so it's not like I don't like typing expressions, because I usually don't like typing expressions. But where you're typing this much, you just type a little extra, and it's the same thing. Yeah, on most cases I would suggest use the wrangle SOP for doing expression based groups. But if you're doing something specific, like you have an existing group and you want to add to that, or you want to subtract from that, then the group expression is better, because this is directly there. I'm very sure you could do it here as well. I am just not sure how. My Vex knowledge is not very good. Like, this is as far as I can go with it. Alright, so that's basically it. So this is most of everything that I know about the new group nodes. If there is anything more that you think I've left out, you can write in the comments. So if it's anything very important, I'll make another video and try to cover it. Or whoever's watching this, you can read the comments and see if I've left out anything. But yeah, this is basically it. And as I said, this should also be useful for anybody who has my previous trainings and you're wondering how to adapt it to Houdini 16, because the groups have changed like a lot. So this video should help with that as well. So as usual, if you have any questions regarding this, don't ask me Vex questions. I am not very good with Vex. Okay, like I'm just starting to learn it. So don't ask me anything very complicated. I won't be able to answer. But yeah, if you have any general questions about Houdini or anything like that, you can ask me in the comment section. You can ask me on Twitter or write me an email, whatever is preferable to you. So that's basically it.